All right, this is going to be a video that deals with complex numbers. And if you are taking my course, this is section 1.3 in our textbook. So the idea of complex numbers, first of all, is we have the imaginary number. So before we can even talk about complex numbers, let's talk about the imaginary number. The imaginary number I is equal to the square root of a negative number, specifically the square root of -1. If we were to take this I and we were to square both sides, then we would be able to say, I squared is equal to just a -1 because squares and square roots undo each other. So what we deal with then in order to talk about complex numbers is that a complex numbers is made up of two different types of numbers. We're combining, first of all, a real number with an imaginary number. And that's what you see right here. The A part is the real part, and the B part is the imaginary part. Now, you'll notice this graphic here is probably something that you have seen on and off throughout elementary school and high school. You started out early on in your math career dealing with natural numbers, and then that grew to the whole numbers and the integers, etc., etc. Well, these complex numbers, then, this is just a whole different set of numbers that combine your imaginaries along with your reals. All right, this just kind of talks about what the square root of that negative means. The square root of a negative is I. So you'll see here that when we take the square root of the negative, the I comes out to the front and the A stays on the inside. All right, so then let's work some questions. When you have the square root of -81, one thing that I want you to start paying attention to here is that you always want to take care of the negative on the inside first. And actually, you're going to see this is rule number 1 here. Always take care of that negative first. So when we look at part A to example number 1, the square root of a negative is I. So we're going to pull that I out front. And then we're left with the square root of 81 on the inside. Well, we know that the square root of 81 is 9. So then we have a 9I. Part B, the square root of a negative, again, is I. And we have that square root of 55, where the 55 remains on the inside. Now, 55 cannot be broken down into any perfect squares, so it's just going to remain as I times the square root of 55. Now, however, on part C, this one's going to be slightly different. Again, take care of the negative on the inside first. So this is going to be an I times a square root of 98. But the number 98 can be broken down into a perfect square of 49 times 2. So the square root then of 49, we know that this piece, just this piece, is a 7. So we will take the square root of 49, which is 7, combine that with the I using multiplication, and then that square root of 2, that 2 needs to just stay on the inside because there are no more perfect squares. All right, I already mentioned that the first rule is to always take care of the negative. Let's take a look at the next two rules. We'll use both of them here in the next couple of sections. Rule number 2 says that you are allowed to multiply and divide insides times insides. You are allowed to multiply and divide outsides times outsides. And you are never, ever allowed to multiply and divide insides with outsides. Rule number 3, when you are adding and subtracting, just combine like terms. All right, so let's go into example number 2. Again, rule number 1 is you take care of the negatives first. Now, so with each of those negatives then, we'll have I times the square root of 21 times the I times the square root of 21. Now, you can rearrange these, and the I times the I is going to be I squared, and the root 21 times the root 21 will be root 21 squared. We know that squares and square roots undo each other, so that's just going to be a plain old 21. And we also know, according to what we said just a few moments ago, that I squared is the same thing as -1. So this I squared is going to be replaced with a -1, and the square root of 21 squared will just be a 21. Multiply and you get a -21. All right, so for part B then, let's take care of those negatives first. So we have the square root of 5 times that I out front, times I, because the square root of a negative is I, times, you'll notice I didn't write 30. I wrote that as a 5 times 6. Now, remember that rule number 2 says that you can multiply outsides times outsides. So that's going to be my I squared. And I can also multiply insides times insides. So it's going to be a 5 times a 5, or a 5 squared, times 6. Again, we know that squares and square roots undo each other. By the way, that only works in breaking it up like that. That only works with multiplying and dividing. And so I'm going to have then my I squared is going to be, I'm sorry about that. I squared will be a -1. The square root of 5 squared is just the 5 on the outside. And then the square root of 6. Clean that up and you'll have a -5 times the square root of 6. All right, let's go ahead and just work D right underneath that. And then we'll slide over and get C here in just a moment. Take care of negatives first. You have your I times, and notice that I broke that up into 7 times 9. And I left the root 21 down on bottom, but I broke it into the square root of 7 times 3. Remember that rule number 2 says that you can divide insides and insides. So in dividing, we know that 7 divided by 7 is 1, and 9 divided by 3 is 3. Now, notice that these were on the inside, so that means my 3 is going to stay on the inside. The I continues to be on the outside, but that square root of 3, that 3 stays on the inside. All right, let's go over to part C then. Again, let's take care of the negatives first. So that's going to be an I times the square root of 42 divided by an I times the square root of 3. Dividing outsides and outsides, my I's will cancel out. Dividing 42 by 3, remember these are both on the inside, so whatever my number is going to stay on the inside. And 42 divided by 3 is 14, and that needs to stay on the inside of your square root. All right, so then continuing on with the next part, let's go to example number 3. All right, so for example number 3, again, rule number 1, take care of the negatives on the inside of the square root first. So let's just leave that 15 alone and the minus sign. Notice that the square root of a negative is I. And then I have the square root of 75, but I broke that into 25 times 3 because 25 is a perfect square. Left the bottom alone, didn't touch that. All right, so let's clean that up a little further. Now, one thing that you'll want to start getting used to doing is that anytime you have a numerator where you have 2 or more things that are being added or subtracted, and then you've got this common denominator, what you are allowed to do is you can split that denominator between the 2 pieces that are being added or the 2 pieces that are being subtracted. There might be more than 2 pieces, but in this case, there's 2 pieces. All right, so that's exactly what I'm going to do then. So I will have 15 over 5 minus 5i. Where did that 5 come from? Well, the square root of 25 is 5. So 5i root 3 over 5 because I'm sharing that common denominator. Now what we can do is we can reduce both fractions. So you reduce the first fraction and you're going to get a 3. And when you reduce the second fraction, remember you're allowed to divide outsides times outsides. So the 5's here are going to cancel, leaving me with just an I root 3.